You're welcome. Okay, so let's go straight into what we have. So the factor and remainder theorems are very important theorems when it comes to the concept of polynomials and especially, division of polynomials. So if we have a polynomial p of x and it is divided by, I already explained this theorem, is divided by, let's say, a linear polynomial x minus a. We noted that all you need to do is pick that divisor, which is x minus a, no matter what the sign is here. If you like, let it be positive, equate it to 0, and then make x the subject of the formula. So by implication, your x is going to be equal to a. So when you have gotten that, we said you should substitute your x into the polynomial you're dividing. Okay, so if I substitute my x as a, so my p of x will now become p of a. Okay, so whatever I get from evaluating p of a will be my remainder. So the factor theorem says that if this is a factor, then p of a must be equal to 0. So that's what factor theorem says. That if the x minus a is not a factor, then the remainder theorem says that your p of a is your remainder. Okay, so that's actually what the factor and the remainder theorem is all about. Okay, so it simply says that if you divide p of x by x minus a, then p of a is equal to 0. This is your factor theorem. While your remainder theorem says that if you divide p of x by x minus a and p of a, let me put it that way, is not equal to 0, then your remainder is equal to that p of a that you will evaluate. Okay, so that's exactly what it is saying. Chinemerem, good evening, you're welcome. Okay, so for instance now, let me give a very simple example before we proceed to other important examples that we're going to do. If I have my p of x to be equal to, let's say, x squared minus 4x plus 4 equal to 0. Of course, if I divide this by, say, x plus 1, all right? So what it means is that if I equate x plus 1 equal to 0, I am going to get that x is equal to negative 1. So if I substitute my x as negative 1 into that polynomial, then I am going to have negative 1 all squared, or of course this is going to be 1 plus 4 plus 4, which is equal to 9. So of course this is not equal to 0. Therefore x plus 1 is not a factor of this polynomial. And so you can now conclude that the remainder for that division is going to be equal to what? 9. Okay, so that's exactly what these two theorems are saying. Okay, so both of them are very beautiful when it comes to the concept of remainder and factor of a particular division in polynomials. All right, so now the question someone will ask is, when I started here, I made mention of using x minus a, which is a linear polynomial. So what about when it is a quadratic polynomial? We are going to see an example like that and how to handle it. Okay, quickly let's go into examples. All right, so look at these examples here. So it says find the remainder when these polynomials are divided by this. So let's begin with the first example here. All right. So now the beauty of remainder and factor theorem is that you don't have to do the division. That division will take your time. So the theorems will just help you to get your remainder or to know whether it's a factor or not. In fact, in some questions, we can actually ask you to prove that a particular polynomial is a factor of the other. Okay, so what that means is that you should just show that if you make your x the subject of the formula in the divisor and substitute into the polynomial, that you're going to get 0. Okay, so let's go ahead to look at this. So it says find the remainder when this is divided by this. Okay, so all I need to do is to pick the the divisor, which is x minus 3, equate it to 0. I'm going to get that my x is equal to 3. All right, so this is the polynomial, so I will just substitute into that polynomial. So my p of 3 is going to be equal to, okay, so what's that going to give me? So very well, this is going to be equal to 3 raised to power 3 is 27. So, and that is going to be equal to my, of course, we can do this one first. Minus 63 plus 33 will give us minus 30. So this will be 27 minus 30, then minus 5. And finally, this will be minus 3 minus 5, which is equal to minus 8. So minus 8 is the remainder for the division in example 1. All right, so I hope that makes sense. So you just get your remainder immediately without any waste of time. So let's look at example 2 here. Here we have 2x raised to power 4 minus 3x raised to power 3 plus 18x raised to power 2 minus 7 divided by x minus 1, and we want to get the remainder. So what do? The same process. You pick your x minus 1 and then equate it to 0. So immediately you will get x equal to 1. All right, so I'm taking all these steps because we are learning. So of course, by the time you start practicing yourself, you don't need to do this because you already know that your x is equal to 1. So you just substitute, and so when we substitute, we'll have 2 into 1 raised to power 4. And so any 1 raised to power anything is 1. So this is 2 times 1, which is 1. And then this is 3. And then this is 18 minus 7. So our remainder is simply, this will give us minus 1 plus 18 is 17. 17 minus 7 will give us 10. And then another thing you should do is at the end of the class, you can find time to try to solve this by using the actual division, and then try to see if you actually get these remainders that we are getting by using the remainder theorem. The truth is that you will definitely get that because it does not lie. So the principle follows. All right. So now look at the example I was talking about. When you are now asked to divide by a quadratic polynomial. You know we have been dividing by a linear polynomial. Please pay attention now. Example 3. X raised to the power of 5 minus x minus 1 is divided by x, okay, x minus 1 and x minus 2. Okay, in some cases we can actually give you this as a quadratic polynomial. That means expanding it. If you are given in such form, you are expected to factorize it like this. That's why you learn factorization under quadratic equation. Now, but in this example, is already factorized for you, so you don't need to bother. And as we go down, you are going to see why you needed to factorize, here before you start solving. Okay, so let's begin. So what are we going to do? Whenever you are given a polynomial and you're dividing by a quadratic polynomial, what do? You are asked to get the remainder. All you need to do is, okay, Loretta, that's okay. All you need to do is, now let me state what I stated before. If I am dividing 9 by 3, it is obvious that I am going to get, okay, no, not 3. Let me use something that will give you remainder. If I'm dividing 9 by 2, it's obvious I'm going to get 4 whole number remainder 1. So, and that means my 9 is going to be, if you multiply what you divided by your answer, and then add back your remainder, you will get back this 9. So 2 times 4 plus 1 will give me back my 9. That's the principle we are using here. We are assuming that if you divide this x raised to power 5 minus x minus 1 by this, that you're going to get something. But we don't want to do the real division. So we now said, let's call that thing we will get q of x, a quotient. Okay? So what it means is that if I multiply that my divisor, which is x minus 1, x minus 2, by the quotient, and then I will add the remainder, that it is going to give me back what I divided, which is x raised to power 5 minus x minus 1. So whenever you are given anything of this nature, you will always write it like this. And then what is your remainder? When you divide by a quadratic function or polynomial, your remainder will be a linear polynomial, which is represented as ax plus b. Okay, so that's what we are saying. So whenever you're given a quadratic polynomial to divide with, you should always represent it this way. And then now your remainder is this ax plus b. So you're looking for a and b that you want to put inside here. And when you put it, that will give you your answer. So just follow us. Let's get this solution. We will do another example and it will make more sense. Okay, so how do you do that? We said you should just you should substitute the way you usually substitute for linear polynomial for 2 of them. That means I will pick x minus 1, equate it to 0, and I will get 1. And then I will use it to substitute here, and then it will produce an equation. So when we did it, when we substituted 1, we got 1 minus 1 minus 1 equal to, you substitute 1 here, you get 1 minus 1 into 1 minus 2. Then you put 1 here, you get x of 1, plus you put 1 here, you get a times 1, which is a plus b. Now, this you now try to evaluate. Of course, this will cancel out. You get only minus 1 equal to 1 minus 1 is 0. So this 0 will cancel out the whole of this, because anything multiplied by 0 is 0. So you will only have a plus b left. So that's going to give us a plus b equal to minus 1. I just interchanged it, and so you call it equation 1. So when you now do for the second one, which is x minus 2, so you will get your x as 2 if you equate it to 0. So if you now substitute it here, you will substitute our x as 2 now. So we'll have 2 raised to power 5. Let me use the blue. Minus 2. Anywhere you see x, you're replacing it with 2. So 2 minus 1. So if we now continue here now, so we now got to 29 here. If you have understood what I explained, Monachi, you respond. And so here, the whole of this cancelled out. And so we got 2a plus b. So we now rearrange it. And then we got 2a plus b is equal to 29 as equation 2. Okay. So solving that equation will now, the two of them, will now give us our a and b. So I will bring down the two equations here. So we have a plus b is equal to minus 1 as equation 1. And then here we have 2a plus b equal to 29 as equation 2. Okay, so let's try solving the two of them. So a minus 2a will give us minus a. B minus b will go away, equal to minus 1 minus 29 will give us minus 30. And so if you cancel this and this, you will get that our a is equal to 30. Okay, so having gotten our a as 30, we can then substitute into equation 1 to get our b. So if we substitute in equation 1 is a plus b is equal to minus 1. So we have 30 plus b is equal to minus 1. Okay, Munachi, that's okay. So our b now is equal to minus 1 minus 30, which is minus 31. And so you will now bring it back to that formula for remainder, which is ax plus b. Therefore, our remainder is, our a is 30, so 30x, and our b is 31, sorry, minus 31. So the remainder for that division is 30x minus 31. And that is the solution for that example 3. That is the solution. And if you do that division practically, you will get the same thing. Now, the issue is some of us will be thinking that doing the division might be better or easier. Of course, I'm going to do the real division now. But this looks longer because we are just learning it. If you understand it and practice, you will see that it is actually very fast. Okay, so now let us do the actual division and see if we will get the same answer. Okay, let's go. Remember, we had x raised to power 5 minus x minus 1. And you're dividing by x minus 1 into x minus 2. It will be important that you open this bracket before you do the division. So if we open this bracket, we'll get x squared minus 2x minus x plus 2. And that's going to give us x squared minus 3x plus 2. Okay, so let's go and do the real division now. So minus 3x plus 2. Okay, so remember that in doing this division, we are going to use only x squared to divide. Alright, so let's start. So if x squared divides x raised to power 5, what are you going to get? You will get x raised to power 3. And now, x raised to power 3 will multiply through. You know how we do it. So x raised to power 3 multiply x squared will give us x raised to power 5. X raised to power 3 multiply minus 3x. You will get minus 3x raised to power 4. Now, x raised to power 3 multiply 2 will give us 2x raised to power 3. Now, follow me. You know we are supposed to put all those ones that are missing here. X raised to power 4 is missing here. X raised to power 3 is missing. X raised to power 2 is missing. Then I want to assume that you already know what to do. So you're replacing them with 0, 0, 0, 0. Okay, so let's go ahead and do this subtraction. So x raised to power 5 minus x raised to power 5 will give us 0. It will go away. Now, there is no x raised to power 4 here, so we can call it 0. So 0 minus 3x raised to power 4, that's going to become positive. You have 0 minus 3x raised to power 4. Minus will be plus. So you are going to have 3x raised to power 4. That's not all. For this one, there is also no x raised to power 3 up here. So you also call it 0. So 0 minus 2x raised to power 3 will become minus 2x raised to power 3. I want to believe that you understood what I did here because you followed me in the previous class. Alright? So here now, you are going to divide again. So x raised to power 2 will divide this. And that's going to give us plus 3x raised to power 2. So we multiply again, and that's going to be 3x raised to power 4. Now 3x raised to power 2 times this is going to be minus 9. Then x raised to power 2 times x will be x raised to power 3. Okay, then it will also multiply 2, and so you will get plus 6x raised to power 2. Okay, now remember to bring down this minus x here, okay, and then minus 1. Bring it down so that you don't forget them. Okay, let me remove this place. Okay, so here now you will subtract to check if there is any remainder. Is there any remainder? Let's see. So this will cancel out. Now minus 2 minus 9 minus 2 plus 9, which is equal to 7x raised to power 3. Now there is no x raised to power 2 in this place, so you also call it 0. So 0 minus 6 is going to be minus 6x raised to power 2. Okay, so and then there is nothing else here, so you also bring down this minus x and minus 1. So you divide again now. So remember, we are dividing with x raised to power 2. So can x raised to power 2 divide this? Yes. X raised to power 2 divide 7x raised to power 3. Be very careful. We are going to have 7x. Okay, so let's go back. 7x times x raised to power 2, that's going to be 7x raised to power 3. And then again 7x times minus 3x. 7 times minus 3 will be minus 21. Minus 21. Then x times x is going to be x squared. And then 7x times 2 is going to be plus 14x. Remember, we are trying to check if the remainder is going to be the same. Okay, let's go on. So from here, we'll try to subtract again. And so this is going to go. Now, minus 6 minus 21 is going to be what? Minus 6 plus 21, which is going to give us 15, positive 15x squared. Please, if you are following me, you can give a thumbs up. I have subtracted for x squared, then we go to normal x. So minus x minus 14 is going to be minus 15x. And then finally, minus 1 will come down here because there is no constant here, so we bring it down. Okay, so I think this is going to be the final division. Let me reduce the size of my board, okay, so that you can still be seeing what I'm writing. Okay, so here now we are going to now divide again with x squared. So x squared will divide 15x squared, and that is going to give us 15. Okay, let me cover here. Okay, so we'll now multiply again. 15 times x squared will give us 15x squared. 15 times minus 3 will give us minus 45x. Okay, minus 45x. 2 will give us 30. Okay, I am sure that by now you should be seeing the answer because it's already there on the board. So let me further reduce this. Okay, so what are we going to have? Okay, so we will now try to subtract finally. So if we subtract now, 15x squared minus 15x squared will go away. Minus 15 minus 45 minus 15 minus will be plus 45. See me now, I'm writing the answer. Plus 45 is going to give us 30x. Then minus 1 minus 30 is going to give us minus 31. If this was a physical class, I expected a clap, but then since you are online, you can just touch something if you have followed me up to this point. So you can clearly see that the remainder we got here is exactly the same remainder that we got from the one we used the formula above to do. Okay, so this is how beautiful your remainder theorem is and the factor theorem. Okay, so, and I don't know which one you prefer. Is it the long division or the remainder theorem? Of course, I will prefer the remainder theorem. Like I said, it looked long because we are learning it. But by the time you keep practicing, of course, before the end of this class, I'm going to drop one exercise on this particular question here. That's this particular type of example, and I will expect you to do it. Okay, so let me increase back this board. Okay, so if you have any question here, you can ask me, but I believe that it is very straightforward. Okay, so now that's how to use the remainder theorem to get the remainder when a polynomial is divided by another. But that's not all that is important to us in remainder and factor theorem. Now let's see other examples that are important. Okay, look at this beautiful example, which is what you find on that thumbnail, the picture that I shared before the class started. Okay, so here we are asked to do this. Please follow me now up to this point. Okay, Modesta, you're welcome. So here it says, for what value of p is x raised to power 3 minus this plus this plus this divisible by x minus p? This particular example, I pulled it from our past question, the same past question I've been using. Meanwhile, when you people come back, I think I'm supposed to snap it and send to you in the group chat. Please remind me in the group so that I will do that, so that you can also use it to be practicing by yourself. Okay, so now this is a cubic polynomial and it's divided by this, and we are asked to find the value of p that will make this a factor of this. So what is this person expecting you to use? He's expecting you to understand the concept of factor theorem. And what is that? For x minus p to be a factor of this, it means that if I equate this to 0 and make x the subject, which is x equal to p, and substitute it into this polynomial, my answer should be 0. So once you do that, you will get an equation, and from that equation you will get the value of p. Did you understand that? So let's quickly do. So we are going to substitute our x as p here. So anywhere I see px, I'll remove it and put p. So I will have p raised to power 3 minus p plus 6 into bracket. I will remove this x and put p. So I will have p squared plus 6p plus c multiplied by, I will remove this x and attach another p, then plus d. So if this is a solution, then this is supposed to, if this is a factor, then I am supposed to get 0. That says you should get p. So your job now is to look for p. So we try to open all the brackets here. So if we open this bracket, from the left, this p will come inside. P squared times p will be p cubed, plus p squared times 6 will be 6p squared. We still close it. Why did I close it? Because there is a subtraction in front. So you will not just open it. You opened it the first time to multiply with p squared. Then you still open it again to multiply with this minus. Then you come over here, open this one. This one is only one bracket. So p into this will give us 6p squared. P times c will give us pc. Then plus d, everything should be equal to 0. Okay, so here now I'm going to have p cubed. If you now open with this minus times this will also be minus 6p squared, and then plus 6p squared plus pc plus d equal to 0. This is so beautiful. Whenever we give you problems in maths, just know that we have solved it and we know what it's going to look like. You see what will happen now. You see all these things are going to cancel out. P cubed will cancel minus p cubed. Minus 6p squared will cancel plus 6p squared. And you are just left with only this small thing. So you just have pc plus d is equal to 0. And remember, you're looking for p. So originally you would think that this thing is difficult. But once you start it, you discover that it's very simple. You see all these things have just gone away. You just have only this small. So you have pc is equal to minus d. Therefore, my p alone is equal to minus d all over c. And if you go to that thumbnail, the picture I sent earlier, I think this is option D. Kindly look at that to confirm. So, but that's just how to use factor theorem. And this is one of the most important applications of factor theorem. If something is a factor, can you get another thing that is missing? There is one example I would have loved to show you. Let me see if I will find it. Okay, let's look at that example. Let me bring it up here. Okay, so look at it. Here you have divided this 2x cubed plus 7x squared, then plus ax minus 1. Okay, so in this case, it says it leaves a remainder. Okay, I'm actually going to remainder in the next example, but let's still put it. So it says that when this is divided by 2x plus 1, that there is a remainder of 3. So it says we should find a. So we are looking for a. What is the value of a? Okay, so what do you do for this kind of example? So here you are now going to apply the remainder theorem. And what did the remainder theorem say? The remainder theorem says that if I equate the divisor to 0, which is 2x plus 1, if I equate it to 0, remember that this is also linear. So that means I'm going to get my x to be equal to minus 1 over 2. So all I need to do is to substitute minus 1 over 2 as my x into this. And since we said that by the time this will divide, that the remainder is 3, that means if I substitute this here, I should get 3. And so it will form an equation and you will solve for a. I think I will allow you to do this and to finish it up. So you will submit your answer for this, get the value of a here. Then before you do that, we'll go to the next example. By the end of the class, let me see your solution for this. Okay, so let's go to the next example. Look at this. This is also talking about remainder. Okay, so it says when ax cubed minus x squared plus bx minus 1 is divided by x minus 2 and x minus 1, the remainders are 19 and 1 respectively. That means when you divide this by x minus 2, your remainder is 19. Let's interpret that first. You interpret it one after the other. So if I divide this by x minus 2, that means if I equate x minus 2 to 0, that's going to give me x equal to 2. So it means that if I substitute my x as 2, my remainder is 19. That means it's going to be equal to 19. So let's do that. Let's substitute our x as 2. So we'll have a into 2 raised to power 3. That means this should be equal to 19. So when you simplify this, 2 raised to power 3 is 8. So you have 8a minus 4 and then plus 2b minus 1 is equal to 19. So if you simplify further, you're going to get 8a plus 2b. So minus 4 minus 1 will give us minus 5. If we take it over to that side, it will be plus 5. And so 19 plus 5 is going to give us 24. Now we can actually call this equation 1, but something can divide through. 2 can divide. So if 2 divide 8a, you get 4a. and if 2 divides 2b, you get b, equal to if 2 divides 24, you get 12. So whenever you have an equation like this and a constant can divide, it's good that you divide through. So our equation 1 is 4a plus b equal to 12. All right? So we got that equation from the first information. And now the second information is that if you divide this same polynomial by x minus 1, your remainder will be 1. That means if I equate x minus 1 to 0 and get my x as 1, therefore that means if I substitute it into that function, my remainder will be 1, meaning it will be equal to 1. Now let's do that substitution. So I'm going to have a into 1 raised to power 3, then minus 1 squared. So I'm replacing 2 with 1. Remember, I replaced x with 2 here before. So I'm just replacing 2 with 1. Then plus b times 1. And then minus 1. Everything should be equal to the remainder. And the remainder is 1. Okay, so this will be equal to 1. So let's simplify. 1 raised to power 3 is 1. So I have a here, minus 1 plus b minus 1 equal to 1. So this is going to give me a plus b. 1 minus 1 is minus 2. If it comes over to that side, it will be plus 2. So 1 plus 2 will give me 3. I can call this equation 2. Alright, so, and you are done. Just solve your equation 1 and 2 simultaneously. So 4a plus b equal to 12, and then a plus b equal to 3. So we are solving it simultaneously, and we can use elimination method. So I will subtract, b can go away. So 4a minus a will give me 3a, and b minus b will go, and 12 minus 3 will give me 9. Therefore, my a is equal to 3. Okay, and so if we now substitute a into either equation 1 or 2, let's use equation 2. So equation 2 is a plus b is equal to 3. And so if our a is equal to 3 plus b equal to 3, therefore our b is going to be equal to 0. Wow, this is very beautiful. So that means for my x minus 2 to have a remainder of 19 and x minus 1 to have a remainder of 1, my a must be equal to 3 and my b must be equal to 0. Okay, so, and that is the solution for this problem. And like I said, you can always do a check for all of these things. If you put back a as 3 here, you have 3x raised to power 3 minus x squared. Your b is 0, so this will go away. So you have minus 1. So you should try to divide this by x minus 2 and see if your remainder will be 19. Of course, we can check that using remainder theorem. So just substitute your x as 2 into this. You will get 19. If you put x as 2 here, that will give you 8. 8 times 3 is 24. Minus, if you put x as 2 here, you will get 4. And so you have 24 minus 5, which is 19. Oh, math is beautiful. Math is beautiful. And so this is exactly what I said to show us in this particular class. How to use remainder theorem and factor theorem to solve problems.